You're listening to the Voice of Russia in London. I'm Tom Spender. Last week, a meteor with an estimated diameter of about 17 meters entered the Earth's atmosphere at a shallow angle near the city of Chelyabinsk in central Russia. Video cameras, some of which were mounted on car dashboards, recorded the meteor as it travelled at about 11 miles per second and detonated in the atmosphere at an altitude of about 20 kilometers. NASA said the explosion released about 500 kilotons of energy, equivalent to about 30 atomic bombs of the type used at Hiroshima. 1,500 people were injured in the aftermath of the blast, which blew out windows and damaged structures. Scientists from Ural's Federal University say they have found about 50 fragments of the meteor, less than a centimetre in diameter, on the surface of a frozen lake. They say a bigger chunk of about 50 centimetres may have broken through the ice and sunk to the bottom. Meanwhile, items touted as fragments of the meteor are reportedly on sale over the internet for as much as £6,500 each. The same day, a much bigger asteroid named DA-14, about the size of an Olympic swimming pool, passed the Earth at a distance of about 17,200 miles, which is closer than the networks, the satellites, used for television and weather networks, which ring the planet. Joining me in our London studio to discuss this burst of meteor activity around the Earth is Professor Alan Aylward of University College London's Department of Physics and Astronomy. Professor Alan Aylward, people naturally wondered if these two events might have been linked in some way, but that's not the case. Is that right?
No, the one that exploded over Russia was actually travelling north to south, whereas we know that DA-14 is travelling south to north. They very often are linked. I mean, we know that comets are linked with meteor showers. We know that we very often see pairs of asteroids together, but these were going in opposite directions, so it's not very likely they were anything to do with each other.
Were they the same kind of object, or did they have similar origins, or were they different, or what do we know about them?
Well, they were both obviously rocky objects, so they were similar in that respect, but. And in fact, most of the objects that come near Earth are either rocky or iron-based. We're lucky that this wasn't more iron-based, otherwise it wouldn't have broken up. We may have actually seen more of it land.
Is that because the iron is denser, or what's the reason for that?
Yes, I mean, what happened with this was it exploded in the upper atmosphere. You get a big build-up of air on the front of it. It's like a jet aircraft trying to break multiply through the speed of sound. That causes the less strong objects to break up. But iron meteorites very often reach the ground pretty well unharmed sometimes.
How many such meteorites reach the ground on the Earth in an average year, let's say? Are there any statistics on this?
Yeah, surprisingly, I mean, there are hundreds of objects every day that are large enough to reach the ground. There's many more that never even get that far, that burn up in the atmosphere. But since most of the Earth is covered in either water or uninhabited areas like Siberia, then you don't see most of them.
Yes, Siberia, of course, where the one of the biggest impacts in 1908, in fact, what's known as the Tunguska event, when an asteroid or comet did explode over Siberia, which apparently leveled 80 million trees over 830 square miles. Was that a similar kind of thing to what we saw over Chelyabinsk?
Yes. I mean, that was obviously something very similar, but the way that the explosion occurred and the damage it did probably means it was a comet rather than an asteroid. So it was, if you like, the explosion was more diverse over and had a wider area impact.
What are the main differences between a comet and an asteroid?
Well, the comets scientists characterise them as dirty snowballs. They're just water or ices of various types, not very well held together. So when they hit the atmosphere, they will tend to explode to really come apart. Whereas an asteroid they're very often rocky. They can have iron cores. They can be quite strong objects. So when they hit, they can do more damage.
And how difficult is it to detect these objects? Because, for example, the one came in over Russia last week was quite small, about the size of a garden shed.
Yep.
And yet it was travelling at 11 miles a second. Is it possible to see these things coming?
Well, they all travel at that speed. I mean, 11 miles a second is sort of orbital velocity for something coming in from outside the Earth's field of attraction. So nearly anything that we run into will either be travelling at that or even faster. Now, there are organisations around the world, some private, some owned like by NASA, which are looking for asteroids in case of something like this, in case one of them is on course for the Earth. Now, most of the bigger ones, like DA14, have been seen well away from Earth. Probably about 80% of those have been tracked. But once you get down below a certain size, you just can't see them. They're just too small to see in a telescope from the ground, especially as they come from a long way away. So there are probably a lot more of these type objects out there. And in fact, we run into one every few decades. I mean, we know about Tunguska because it occurred over land where it did some damage. We know about this one because we obviously saw the results. But there's probably every 10, 20 years or so, something like this happens over the sea where we don't see it.
And now, over to our studio in Washington.
Thanks so much, Tom. I'm here with Dr. David Dunham, who works at KinetX and is the lead scientist at the Laboratory for Cosmic Research at the Moscow Institute of Electronics and Mathematics. This is Rob Sachs, of course, here at the Voice of Russia in D.C. And Dr. Dunham, wanted to ask you a little bit more about the fallout from this big meteor. We heard earlier Tom talking about how people, there's a scramble to collect these meteors all over, and that you can get almost as much as, I'm seeing, $16,000, 500,000 rubles for a fragment. Why are they so valuable? What can we learn from these little pieces of rock?
Well, certainly an important thing about this is to learn how these things break up in the atmosphere, and in order to do that, you have to know what they're made of. So any debris left from these explosions are very interesting to the scientists to try to figure out what the parent body was. Then we can take better defense against whatever is out there.
So when you're analyzing one of these meteors, what are you looking for? The chemical compounds of it? What can the various parts of looking at this under a microscope tell you about the object from the sky and tell you about the universe in general?
Well, you can look at the isotopes. You can tell the age of the object or how long it's been exposed to cosmic rays in space and so forth, depending upon how deep inside the parent meteoroid the object was. So I'm not really an expert at the physics of this. Maybe Alan can say more about that. I'm more an orbital design guy. So.
Well, maybe we'll get Natan Eisman, our guest in Russia, to weigh in on that. He is a leading scientist at the Russian Space Research Institute of the Russian Academy of Science. Natan, welcome.
Welcome.
So what is it then we're really trying to figure out and dissect when we look at this, the characteristics of these meteors, and what can we really glean about the world apart from what's going on planet Earth?
Studying, exploring these bodies which came from the cosmos, we can better understand the origin of the solar system. We can understand, as just David told, the age of the solar system, and we can compare those chemistry of the soil on the Earth, and compare it with the species which came from the space, and it helped to explain was the evolution of the solar system and what expect us in the future. And so, in this sense, these species collected after they reach the surface of the Earth, they are very, very useful for the science. About the origin of these bodies which reach the surface of the Earth, there are some small stones which are suspected to come even from the Mars surface. Sometimes there are some arguments about what was the genuine origin of these bodies came from the space. But in any case, it helps us to understand the evolution of the solar system.
Well, wanted to also ask you, Natan, about these meteors that come to us, and we talked about how you can get a lot for them on the market, but talking about the price of exploring meteors versus actually going out and putting a rover on the surface of Mars, it seems to be a lot more economical to get what comes to us rather than trying to go there.
That all these automatic vehicles which are used to explore the planets, explore maybe some small bodies in near future, they are equipped with some devices which allow us, without delivering the species to the Earth, to understand better the composition of the soil of the Mars surface, for example. But it's more reliable for scientists to receive these samples from the Mars surface, to explore them here in the Earth's laboratories. So, for example, that unsuccessful mission to the Phobos satellite of the Mars was intended to return back the samples of the Phobos soil, and that it was important not only to understand the origin of this Phobos Mars satellite, but there were some assumptions that the samples from the Mars, after Mars is hit by the asteroids, the dust may reach the Phobos, and so there were hopes that delivering the soil samples from the Phobos surface, we can simultaneously to receive some samples from the Mars surface. But unsuccessfully, unluckily, this very ambitious mission has failed, and so now the Russian scientists, they propose to repeat this mission maybe in 20s. It means that the interest to get some materials from the surface of the planets of the solar system still is kept as very important for the studies or exploration of the solar system.
Professor Alan Aylward, we've talked about the meteor that came in over Russia, but DA-14 would have been quite a different proposition because it was that much bigger. Ultimately, is there anything that we would be able to do in the event such an asteroid was headed for the Earth?
I think at the moment, no. I mean, apart from sending Bruce Willis out, it's very unlikely we could actually do very much about it. If we had enough notice, possibly. I mean, there are some projects at the moment where there are lots of groups looking at ways you might divert them if you get enough notice. There's one coming back in, I think it's 2026, Apophis, which will miss the Earth again by a few tens of thousands of kilometres. But as it passes the Earth, will be deflected, and the worry is that the next time round it could actually hit. And this is something of the size of DA-14. So there are groups looking at what could you do? Could you divert them? Could you try and break them up? But what we need is to know where they all are before we can do that.
What kind of techniques could one use to divert a hurtling asteroid the size of a swimming pool?
Oh, well, there are a number of things being tried. There's a group actually in Scotland that are looking at the idea of using lots of small craft around them with lasers on, burning away at one side. You get a little bit of thrust if you burn one side of it. So you gradually nudge them. If you can do that for year and year on end, if you get enough notice and it's coming around in 10 years' time, and you sort of work away at one side of it, you can nudge it out of the orbit just enough to miss the Earth when it comes around next time.
That is completely astonishing. Natan Eisman in our Moscow studio. I want to ask, how much excitement has this a meteorite hitting or rather exploding over Russia generated in Russia itself? Is there a newfound enthusiasm for cosmology and the like?
Yes. You know that this meteorite attract a lot of attention in all fields, connected and not connected with the cosmic research. So the high-ranking officials, they immediately propose their own idea how to prevent this asteroid to hit the Earth. But even before, in the laboratory headed by David Dunham, the studies began, which are aimed to develop some methods to deflect the dangerous or hazardous asteroid from collision from the Earth. And one of these mode proposed now in the development study is the method supposing that for the hazardous asteroids, the smaller ones can be used by targeting them to this hazardous asteroid. One received the possibility to deflect this dangerous asteroid from the collision with the Earth. But one can ask, how do you intend to do it? Because even small but dangerous asteroids are too big in order to use traditional mode to change their motion. The idea is to use for these dangerous asteroids the smaller ones, which can be targeted to these dangerous ones using so-called gravity-assist maneuver near the Earth. And in this case, the cost of the deflection of the hazardous asteroid is much smaller than in case of when we use the traditional approaches. For example, some of the near-Earth asteroid can be put on the required orbit reaching the hazardous asteroid by the velocity impulse not exceeding the 2 meters per second. It's very small impulse. But it was shown that it's possible to apply this technology when we can reach the high enough accuracy in control of this small asteroid.
Well, just to jump in off that and to get our American guest, David Dunham, back into the conversation, wanted to ask you, thinking about this, it's almost like an Iron Dome system for asteroids, but would this be something that would be based here on Earth, or would you have to set up something on the Moon or the International Space Station? How would you best position yourself to intercept an object hurling itself toward Earth?
Okay, well, as Natan described this effect of using small asteroids. Now, these are objects like 5 meters across or so, 5 to 10 meters, a little bit smaller even than the Chelyabinsk event. And these are being discovered more, but there are millions of them out there that we don't know about yet. The idea is to try to move one of these things, one of them that is already naturally passing close to the Earth, to change its orbit so it moves by the Earth in a different way, and the Earth's gravity then gives you a much bigger lever arm to change the orbit of the small asteroid, so you can move it into the path of Apophis or some other dangerous asteroid.
So it's almost like asteroid billiards here.
Exactly, exactly. And this isn't just science fiction. There's a group in California, the Keck Institute, who has studied capturing small asteroids like this, using a system that would envelop the asteroid, just wrap it up, and then using the rocket that arrived there to move it, nudge it slightly, and then use weak stability boundary regions near the Earth to move the object actually into lunar orbit. It could be captured by the moon and then put into a safe orbit around the moon where it wouldn't hit the Earth and could be mined and studied. Well, our idea is to do the same thing, but instead of just capturing it to the moon, we just move it to a different place near the Earth so it swings by the Earth to go to a destination that would stop an asteroid, a more dangerous asteroid.
Wanted to ask you real quick, though. I just saw this documentary about how much space junk is already in our orbit, and how much, and people talk about this being a 100-year event, but how much are we in danger of following satellites and other things coming in and disrupting our everyday lives because of the growing amount of space junk out there that could be, more of an imminent threat than maybe an asteroid?
No, there's not as much junk that we've put out there that's already the natural threat is larger than the man-made one. There certainly is a man-made threat. There was a rocket engine that fell on a farmer's, in a farm near Texas a few years ago that was a space junk object like that. So yeah, they can do that. And I've heard that some soldier or some people on a ship off of Japan were injured by a falling satellite several years ago. But there's nothing out there. I mean, the International Space Station, of course, is pretty large, and the Mir space station, they steered it so it would fall over the Pacific and where it wouldn't hurt anyone. But when it came down, the natural threat is still much larger. I mean, there's much bigger objects out there than anything we've put into orbit so far. And also they're traveling much faster because they're coming away from in solar orbit rather than from Earth orbit. I wanted to mention, though, that one problem, there have been a number of small asteroids that have been observed approaching the Earth, and one in 2008 was actually seen before it impacted the Earth, and the orbit was very well observed, and then it exploded harmlessly over northern Sudan. This was because it was only a 4-meter object. It wasn't as big as the one over Chelyabinsk, so it didn't cause as big an explosion and couldn't hurt anyone then. There were just a few nomads. Someone with a cell phone camera out there actually got a picture of the dust trail afterwards, and they picked up rocks from it. But the problem with Chelyabinsk is that the object came from the direction of the sun. And so that's the problem, is we don't know a lot of these things, and they can come either from the night side or the day side. And if they come from the day side, we don't have any warning except from the flash, and then a few minutes later the shock wave will hit you, like happened in Chelyabinsk. We have an idea of how we might be able to see these objects a day or so beforehand. And that's because there's a balancing point in the gravity between the sun and the Earth, about 1.5 million kilometers or 1 million miles towards the sun, called the L1 libration point. And we've already put several satellites there to study the solar wind and to study the sun and other things like that. But I have an idea that we could put a space telescope there that would look at the vicinity of the Earth continuously, and we could spot these things. There's a group called the B612 Foundation in California that's already designed a very capable space telescope for detecting asteroids. And they plan to put it into orbit near Venus so that it could be in a Venus-like orbit. It could look out at the Earth's orbit and find lots of asteroids, but it will find the ones 100 meters and larger. So, as you say, swimming pool-size objects, and things like DA-14. It'll find most of those, not all of them, but it'll find most of them. Over its 6-year period, it should find about 90% of them or so. But if you could put a copy of that spacecraft at the Sun-Earth libration point and look towards the Earth continuously, we'll see events. We'll see asteroids down to only a few meters across. And then once it sees it, then you can predict where and when it will hit the Earth if they're on a collision course with the Earth. Of course, most won't be, but as we say, every 15 years or so, one will be that's large enough to do some damage. And so instead of having only that 2-minute warning, we'd have several hours of warning. And especially if it's a larger object like DA-14, something as large as caused Meteor Crater in Arizona that could wipe out a whole, like a whole area like the size of France.
Well, we want to get into that, but I know we have to go to break. Tom, I'll let you introduce us into our newscast.
That's right. We're just going to have a very short news update now from the Voice of Russia in London.
You're listening to the Voice of Russia from the heart of London. On weekdays, we broadcast live from 4 p.m. until 8. We'll bring you news, current affairs, features and debate. You can listen to us on digital radio and online. Visit ruvr.co.uk.
Well, welcome back to the Voice of Russia in London. I'm Tom Spender, and I'm joined in the studio by Professor Alan Aylward of University College London's Department of Physics and Astronomy, and we're talking about last week's meteor detonation above the Russian city of Chelyabinsk and the larger asteroid known as DA-14, which narrowly missed, at a distance of about 17,000 miles, the Earth on the same day. Dr. Alan Aylward, we've been listening to our other guests in Moscow and Washington talk about some of the tactics that could be used to deflect asteroids and also the difference in the direction that they come from, making it more or less difficult for us to detect them. In this case, the asteroid that came in over Russia appears to have come from the direction of the sun, and that made it more difficult to spot. I wonder if you could just tell us why it's more difficult to detect an asteroid if it comes from one direction or another.
Okay, well, obviously you understand that if it comes in during daytime, it has to be a certain brightness before you'd see it in the sky. But also, if you're looking in a telescope and you're looking out into the sky looking for objects, if they're near the sun, then obviously the sun's light swamps anything that you're likely to see. So there's always an area around the sun which you can't go looking, because you need sensitive detectors to see these things. I mean, you can imagine something that's only 4 meters across, millions of miles out in space. You're just looking at the reflected light from it. They're very, very dim. So your instruments are very sensitive. So you just don't look too close to the sun, otherwise you destroy the instrument that you're using to look for them. So that means that you have to be a certain distance away from the sun, and that restricts the area in which you can look for anything that's coming towards you from that direction.
But given the way the Earth turns, is it not possible for one station somewhere on the globe to be looking in the direction where another station somewhere else on the globe can't look?
Well, if it's towards the sun, it's towards the sun. It doesn't really matter where you are. It's going to be swamped by sunlight. Yeah.
So we're still looking. None of this is really how do the telescopes detect other objects that are travelling fast? I understand that they compare and contrast images taken a certain amount of time apart.
There's a standard technique for doing it. You image a certain part of the night sky, and then you take another image a little bit later, and then they use a technique where they basically they look at one and then the other, and they flash them on very fast. And so the difference between them is seen as an object that seems to flash backwards and forwards between two different positions. So that's how a lot of the observers who are looking for these actually find the objects. Sometimes, if you just take a picture of the sky in a certain direction for a long time, you see a streak across the sky where the object's been moving.
And we've heard a lot about some of the fantastical schemes, none of which have ever been tried, as far as I'm aware, to deflect or capture asteroids and meteors, or stick them in, to store them in an orbit around the moon, and so on and so forth. So there's obviously a lot of creativity being brought to bear on the potential rather thorny issue of large asteroids hurtling towards the Earth. Are these attempts kind of joined up around the world, or do we see an element of competition between different laboratories? Is there enough information sharing? What do you think?
I think there's lots of information sharing. I mean, people go to conferences and they discuss these ideas. I wouldn't say it's joined up. It's a pretty difficult topic, and it's also a very expensive topic, and you've got to try and convince somebody to pay for it. So yes, there's a lot of competition for any money there might be there, but the plans are not really well enough developed. I mean, I like the idea earlier on of this cosmic billiards, where you could you imagine how frustrating it would be if you spend all that money, you deflect one towards another, and you just miss it?
Well, yes, absolutely. And we are, of course, in a kind of financial crisis period at the moment for certainly for some of the countries with more established space operations. I mean, how does that put us more at risk, do you think, or not really?
It's difficult to say. I mean, it's whether or not we would be doing this sort of thing even if we had a larger space budget. I'm not really sure. The Americans are, I think, the next step of their space program. They will possibly try to attempt to land on an asteroid, or they'll look at something that's passing close to the Earth, because it may be easier to do that than, for example, to go to Mars. So actually, we may already be getting to the stages where we are going to start looking at some of these, landing on them, taking samples of them, trying to find out more about them. And maybe while they're doing that, they'll end up with a system that can actually usefully land and deflect them. One idea is to land a thruster on one of these objects and use that to nudge them out of the way. The whole thing comes really down to how much notice you've got. If you have years before the thing is going to strike you, you don't need very much thrust to move it out the way. The problem comes is if you only see it a couple of days before it hits, then there's very little that you can do about it.
Let's get the perspective from our guests in Washington and Moscow.
Yeah, on that note, David Dunham, wanted to ask you, how much money is there in the budget for NASA or the American Space Program, or for whatever labs that are working on this, to actually build something like this? I imagine it'd be very costly.
Oh, yes. There's no budget at the moment, but this whole planetary defense against these objects is taking greater notice. As we realize that there are more of these objects that are whizzing around out there that can harm us, and now that with Chelyabinsk, it's actually something's happened, and so people. The NASA has increased its budget. There was a budget of about $7 million for funding the near-Earth object search surveys, and that was increased last year, or the current year, to $21 million. So that's with the PanSTARRS and the LSST programs are increasingly to find these things, But of course, we really need something a little bit more. This idea of this Sentinel telescope that the B612 Foundation is supporting it's a private foundation. It's not NASA, but they've done a design for this. It's based upon the NASA spacecraft, the Kepler spacecraft, which is discovering planets orbiting other stars. It's sort of a similar technology.
Well, I want to get Natan Eisman to just weigh in on the Russian venture to kind of attack these things after Chelyabinsk. What's going on over there?
That the Vice Prime Minister, Mr. Rogozin, immediately after this case near Chelyabinsk, he proposed to build some system of defense from this threat from the skies. No detailed plans were up to now been proposed, but there is some understanding on the higher level of the Russian bureaucracy that it is the real problem, and so we expect that more attention will be put for this problem, which means to increasing of the financing of the exploration and studies in this area. Really, there are technical possibilities in Russia to improve or build from the practically zero the system which at least will allow us to detect and track this asteroid. And this system needs not only some optical instruments, but also some radar system, because for reaching high enough accuracy of knowledge of ephemeris or position of these asteroids, we need to add to the optical tracking, the tracking by radars. With the radars, we can improve the accuracy of our knowledge of position of these asteroids approximately by one order. So I mean the error will be decreased by 10 times. And it was proved by the experience with this supposed to be dangerous asteroid.
Mr. Eismont, I'm going to have to interrupt you here because we're running out of time. I'd like to thank all of our guests for joining us today on our discussion about asteroids, near misses and hits. In the studio in London, Professor Alan Aylward of UCL in Washington, Dr. David Dunham, Chief Mission Design Engineer at the company KinetX, and in our Moscow studio, Natan Eismont, a leading scientist at the Russian Space Research Institute of the Russian Academy of Science. You're listening to The Voice of Russia in London. I'm Tom Spender. Last week, a meteor with an estimated diameter of about 17 meters entered the Earth's atmosphere at a shallow angle near the city of Chelyabinsk in central Russia. Video cameras, some of which were mounted on car dashboards, recorded the meteor as it traveled at about 11 miles per second and detonated in the atmosphere at an altitude of about 20 kilometers. NASA said the explosion released about 500 kilotons of energy, equivalent to about 30 atomic bombs of the type used at Hiroshima. 1,500 people were injured in the aftermath of the blast, which blew out windows and damaged structures. Scientists from Ural's Federal University say they have found about 50 fragments of the meteor, less than a centimeter in diameter, on the surface of a frozen lake. They say a bigger chunk of about 50 centimeters may have broken through the ice and sunk to the bottom. Meanwhile, items touted,
if you like, the explosion was more diverse over and had a wider area impact.
What are the main differences between a comet and an asteroid?
Well, the comets scientists characterise them as dirty snowballs. They're just water or ices of various types, not very well held together. So when they hit the atmosphere, they will tend to explode to really come apart. Whereas an asteroid they're very often rocky. They can have iron cores. They can be quite strong objects. So when they hit, they can do more damage.
And how difficult is it to detect these objects? Because, for example, the one came in over Russia last week was quite small, about the size of a garden shed,
yep.
and yet it was travelling at 11 miles a second. Is it possible to see these things coming?
Well, they all travel at that speed. I mean, 11 miles a second is sort of orbital velocity for something coming in from outside the Earth's field of attraction. I mean, we know that comets are linked with meteor showers. We know that we very often see pairs of asteroids together, but these were going in opposite directions, so it's not very likely they were anything to do with each other.
Were they the same kind of object, or did they have similar origins, or were they different, or what do we know about them?
Well, they were both obviously rocky objects, so they were similar in that respect, but and in fact, most of the objects that come near Earth are either rocky or iron-based. We're lucky that this wasn't more iron-based, otherwise it wouldn't have broken up. We may have actually seen more of it land.
Is that because the iron is denser, or what's the reason for that?
Yes, I mean, what happened with this was it exploded in the upper atmosphere. You get a big build-up of air on the front of it. It's like a jet aircraft trying to break multiply through the speed of sound. That causes the less strong objects to break up. But iron meteorites very often reach the ground pretty well unharmed.
As fragments of the meteor are reportedly on sale over the internet for as much as £6,500 each. The same day, a much bigger asteroid named DA14, about the size of an Olympic swimming pool, passed the Earth at a distance of about 17,200 miles, which is closer than the networks, the satellites, used for television and weather networks, which ring the planet. Joining me in our London studio to discuss this burst of meteor activity around the Earth is Professor Alan Aylward of University College London's Department of Physics and Astronomy. Professor Alan Aylward, people naturally wondered if these two events might have been linked in some way, but that's not the case. Is that right?
No, the one that exploded over Russia was actually travelling north to south, whereas we know that DA14 is travelling south to north. They very often are linked times.
How many such meteorites reach the ground on the Earth in an average year, let's say? Are there any statistics on this?
Yeah, surprisingly, I mean, there are hundreds of objects every day that are large enough to reach the ground. There's many more that never even get that far, that burn up in the atmosphere. But since most of the Earth is covered in either water or uninhabited areas like Siberia, then you don't see most of them.
Yes, Siberia, of course, where the previous, the biggest, one of the biggest impacts in 1908, in fact, what's known as the Tunguska event, when an asteroid or comet did explode over Siberia, which apparently leveled 80 million trees over 830 square miles. Was that a similar kind of thing to what we saw over Chelyabinsk?
Yes. I mean, that was obviously something very similar, but the way that the explosion occurred and the damage it did probably means it was a comet rather than an asteroid. So it was